Probability density functions. The probability distribution of a discrete random variable shows the likelihood of each possible value it can take. This is given by its probability mass function or probability density function, written as probability of x equals x. Sometimes you just see it given as that. These may be expressed as a table, a formula, or a graph, as we will see in the example below. A discrete probability function has the following properties. Now, before we go into this, we met one in the introduction. We had a standard fair cubical die, and we said that x, capital X, was the random variable, the number showing on the uppermost face. And the probability was 1/6 for each possible value of x. So those were 1, 2, 3, 4, 5, and 6. And we said 0 for any other possible value. So you can't get a 7.9 or something when you roll a 6-sided die. Bear this one in mind as we go through the properties below. The first one says the probability of x taking any particular value has to be between 0 and 1. And we know this from earlier work. Probabilities have to be between 0 and 1. So that's true for all values of x. The sum of all of the probabilities has to be 1. We know that probabilities can't be greater than 1. And if it was 0.9, then we're missing 1. It has to come to 1. P of x is a function, so each value of x gives only one value. What we're saying here is, let's say we have 2 here. We can't have one probability of an eighth and another one of a third, both pertaining to that value. Each individual value in the domain must give you a specific single probability. So, the sum of the probabilities must be 1, and none of the probabilities may be negative. And that's how we can recognize what is a probability density function from something that isn't.